Good morning, FHS. Today is Wednesday, January 24th. Would you please join me in a minute of silence? Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you and have a great day.
All right, so last time we started talking about limits and what limits look like on a graph. We did a couple quick questions with practice on that. Guess I'll ask for that next time. I meant to ask for it today, but it's okay. It's not on the agenda, so just make sure that you keep up with that. But you only had one handout this morning, but I went ahead and just combined two of our handouts together to save paper. So the front of this, the notes, is going to be 66, and the back is 67. So we've got three things to do today. We're going to talk about the next piece of notes, which you can see is pretty short, not real complicated, but we're going for quality over quantity here. We need to understand why it works the way it works so that you can remember it a couple weeks from now. Then you'll practice that skill on the back. That would be the second thing. And then the third thing, I've got a Khan Academy assignment over what we did last time. And it's very short, but we'll talk about it when we get there. Okay, so right now, given a graph or given a table, you should be able to tell me what the limit is, if you understand what that is asking for. But now we're going to do the same thing, but instead of being given a graph or a table, we're going to do this analytically, which just basically means with algebra. So let me just quickly say, like, 1, 2, 3. Let me try to connect what we did last time to what we are going to be talking about today. So if we knew what a function looks like x squared, if I wanted to know what's the limit as x approaches 3, so we had to make sure that it's approaching the same y value on the left and the right. So from the left side, it approaches a y value of 9, and from the right side, it approaches a y value of 9. And since those were the same, that ended up being the answer to the question. But sometimes it's more complicated than x squared. It's not necessarily something that we know. Also, remember that like if there was a hole here, this still equals 9. Or if there was a hole here and the point was somewhere else, this still equals 9. Because limits are not points. Limits are only describing the y value it approaches. It doesn't care what's happening at that value. But that being said, if it's a nice continuous function, to be continuous, it can't have any vertical asymptotes or holes, which occur when you try to divide by 0. Then the point is going to be there, and the values it approaches from the left and the values it approaches from the right will be what the point is. So, when we do this algebraically, here's the same question. We always start off with a process called direct substitution. And you hope that this works. Direct substitution simply means I'm going to plug this guy in to whatever the function is, and if I get a real number like 9, we can assume that that's our answer. So I don't have to see the graph of x squared. I don't have to try to graph it. I don't need a calculator to graph it. We can just plug it in, and if we get a real number, that is our answer. So even on the back of this, when we you practice some of these, there is, I see at least 3 questions just at first glance. That direct substitution is all you have to do. You plug it in and it works. The reason why this works is because this has a point at 3, 9, and because it's continuous, that means it's approaching 9 from the left and approaching 9 from the right. But sometimes what's going to happen is you're going to start off with direct substitution, and you're going to get something that's not continuous, like 4 divided by 0. So what happens when we try to divide by 0? Okay, so this fraction's undefined, so therefore we say the limit does not exist. This graph looks roughly like this. So from the left side, it approaches negative infinity. From the right side, it approaches positive infinity. But for the limit to exist, it has to approach the same number on the left and the right. Once again, direct substitution still worked for this. I plugged it in. We cannot divide by 0. So our limit does not exist. Now, here's where we're going to be spending a lot of the next week. There's lots of different tricks when it doesn't work out that nicely. Today we're going to focus on one specific trick. So on question 3, if you try direct substitution, your numerator goes to 0 and your denominator goes to 0. And honestly, this is one of the first big problems that calculus tackles that you've never had to learn in another class. You should have learned that if you take 0 divided by any other number, it's 0. But then just like this last question, if you take some other number divided by 0, it's undefined. But if you have a fraction going to 0 over 0, it could be anything. It could be 0, it could be undefined, it could be 5, it could be 2.5, it could be lots of stuff. It depends on how fast the numerator is going to 0 and how fast the denominator is going to 0. So this is what we call indeterminate form. 0 over 0 is called indeterminate form. That's the problem we're going to work on for the next few classes in just different ways. Now, the way to do this analytically, again, assuming you don't have a calculator, because if you had a calculator, you could graph this as a graph, and then you could look at the question like we did last time, and I think that's good to check, but we won't provide you a calculator on a lot of our stuff, so don't use it as a crutch to get to your homework. What we have to do is we have to make this look different. We have to use our algebra skills, our trig skills, our fraction skills, our exponent skills. We need to make this look different. So today, the only way you're going to have to manipulate this is with factoring. We could factor the numerator, try to factor the denominator, and if it's an indeterminate form, something should guarantee to divide out. So let x minus 4 cancel out x minus 4. Now that those have canceled, you can go back to direct substitution. So I had to start with it, and now I'm going to go back to it. I'm going to plug 4 into what's left over. And if that's a real number, we can assume that that's our answer. So the majority of the work here is just factoring, which of course you guys can do and have some experience with, but you need to understand why. Try to just plug it in. If you get a real number, that's your answer. Try to just plug it in. Something else divided by 0 still doesn't exist, so the limit does not exist. But if you do direct substitution and you get 0 divided by 0, you have to make this look different, and each day we're going to keep adding on to our tools, but today we only have to factor. Try to factor both, get something to cancel, and then try direct substitution again. And if you end up with a number, you can assume that is your answer. Okay, and that's it. So let me say that again on these last 2 more examples here that you copy down for your notes. Always start with direct substitution and hope that it works. But if you get 0 over 0, you need to algebraically, or with trig identities, or with fractions or exponents, any way you can. Again, today you only have to worry about factoring, but try to factor the numerator, try to factor the denominator, and you need something to cancel before this will work. In this case, the x minus 5 cancels. And then as soon as something cancels, direct substitution will probably work. So plug it into what's left over. If you get a real number, you can assume that that's your answer. If I looked at this graph and I thought about what y value this was approaching as x approaches 5, it's approaching 10 from the left and 10 from the right. I don't have to have a calculator to graph it. I don't have to have the graph drawn for me. I don't have to have a table. We can do it with just those algebra steps. Okay, one more time. I'm going to say the exact same thing, but you really need to think of this in 3 steps. Step 1, direct substitution. Hope you get a real number, because if it is, you're done. If you get 0 over 0, you have to algebraically simplify this before direct substitution works. So factor the numerator. If you have to slow down and do the product sum, if there's something about that combination of trinomial that you're struggling with factoring, then you need to do that. Try to factor the denominator, and something has to cancel. So if nothing's canceling, you need to double check your factoring. In this case, it looks like the x plus 1s cancel out, and as soon as something cancels out, step 3, direct substitution should now work to finish it up. Looks like we get -3 over -4, which is the same thing as 3/4. So again, the bulk of your time is going to be factoring GCS, factoring trinomials, but you have to force yourself to structure this in your head to move forward successfully. Direct substitution is all you need sometimes. Always start with that. If you get 0 over 0, try to factor, get something to cancel, and then direct substitution should work. Okay, so let me give you a few minutes to, and then I'm not going to insist that you do this on all 18 questions on the back, but a couple times you really should, just to make connections with what you did last time. Graph the function in your calculator, and then make sure that the limit looks like it's approaching what it's approaching from your answer. All right, so flip it over, and if you would, try to work these in order so that as you guys have questions, everyone has tried them. So try question 1 before you try question 2. Try question 2 before you try question 3. And we'll put a dent in this assignment, and then I'll explain the last part, the Khan Academy thing. Khan Academy is going to be very short, but right now I want you to focus on this. Push. Okay, let's do a quick check over the first two. And then I will talk about how to check. I'll say that one more time. So step 1, just plug it in, direct substitution. The numerator goes to 0. The denominator goes to 0. This is what's called indeterminate form. This is the only indeterminate form that you need to worry about right now. This is the one that takes some more work. You need something to reduce. You need to make this look different. So you should have factored out a GCF out of the top, 12. You should have factored your trinomial on the bottom, x minus 5, x minus 1. Something has to cancel. In this case, the x minus 5s. And then once something cancels, you can try direct substitution a second time. Plug it into what's left over. 12 over 4 should give you 3. That means that this function approaches a y value of 3 from the left and right as x gets closer to 5. That's what we're describing when we say the limit. So, same 3 steps on number 2. You try direct substitution, you get 4 over 0. 4 over 0 is not indeterminate form. Only 0 over 0 do you have to factor and get something to cancel and do more work. Any other number besides 0 divided by 0 is undefined, which makes the limit not exist. The limit does not exist. Again, it's not the algebra here that should be giving you a lot of trouble, but trying to see how these pieces fit together. Now, if this was one I was going to check, again, I don't anticipate that you're going to check all 18 of these in your calculator, but you really need to force yourself to do it on 2 or 3 before you're finished, so that you know that if we make part of your next test calculator allowed, that you could do this as a backup. So, for question 1, you can graph the function. Make sure that you either type it in as a fraction or put parentheses around your numerator and parentheses around your denominator so that your calculator handles that correctly. And then what we're trying to do is we're trying to find the limit as x approaches 5. So if you hit trace 5, enter, it will jump to that y value. So move the cursor a little bit to the left. So it looks like as x approaches 5 from the left, the y value is getting closer to 0. Move it a little bit to the right. As x approaches 5 from the right, the y value appears to be getting closer to 0. And if it's approaching 0 on the left and 0 on the right, that is not what I got on my paper. What did I do here? X squared minus 6x.
It's plus 5, it's not minus 5.
Oh, it's plus 5. That didn't print off well. Okay, so yeah, this was plus 5, but I typed it in as minus 5. Okay, but assuming I had graphed it correctly, you could see how that could help you catch your mistake. It didn't match up with what I had on my paper. But now, trace 5, enter, goes to that value. It does not exist there. That doesn't mean the limit does not exist. You have to differentiate the difference between a point and the limit. Limit cares what is it approaching. So move your cursor a little bit to the left. As x approaches 5 from the left, it looks like the y value is getting close to 3. Move your cursor a little bit to the right of 5. So as x approaches 5 from the right, it looks like the y value is approaching 3. And if it's approaching 3 from the left and 3 from the right, the limit is 3. If you graph it in your calculator, and then it's exactly the same thing that we did last time. Last time I just provided all the graphs for you and didn't make you think about it algebraically. Okay, and then if I wanted to check question 2, I'll do one more of the checking. Again, you can graph it and then apply what we did on the first day of limits. So as x approaches 2, hit trace 2, enter to jump to that point in the graph. When x equals 2, y doesn't exist. That means the point doesn't exist. That doesn't necessarily mean the limit doesn't exist. You have to move the cursor a little bit to the left. See that it's going down. I don't know. It's going down real fast. So this is like negative infinity. Move the cursor to the right of 2 to think about what y value is approaching as x approaches 2 from the right. And it's way up here. It's approaching positive infinity. If it's approaching something different on the left and something different on the right, that limit does not exist. It has to approach the same number on the left and the right. Okay, so I was just trying to help you catch a few of your mistakes, but keep on going. Again, please do in order the 3 down the left side, just in case you have some problems. Everyone will have had a chance to try it and benefit from me going over it if we need to. Sorry, while you guys work on that, I do need to, I guess, mention some information with CAP. So in advisory yesterday, you guys should have started the CAP process, getting a reminder how to put those course requests in HACK, and I think you should have done math and English. Of course, those are not set in stone until after the CAP appointments come and go. But for you guys, of course, I'd recommend most of you for AP Calculus AB. That's really the whole point of pre-calculus, is to practice the algebra, the trig, and limits are the only full calculus thing we do all year to help prepare you for that. But of course, I know not everybody has time for that in their schedule. So there are other options. Of course, again, most of you I know will pick AP Calculus. It is an AP level course. It certainly requires more work than this class. It requires more outside class time. But in general, sometimes I would suggest that if you talk to your friends that are in a specific math course that you're interested in taking, sometimes they can give you a little better input. If you're not thinking of doing AP Calculus because you don't think you're going to pursue a career in math or science, that's fine. But some other good options would be like AP Statistics. That's very good, especially if you're going into business. And it's an AP level course too, so there's still a chance for college credit. If not that, college algebra and finite are good choices. Those are through NWAC, so those are no AP test at the end. If you pass them, then you get the college credit. So that one's good. And next year we are going to try to offer a new class that some of you might be interested in. And that new class is going to be AP Pre-Calculus. This year was the first year that anybody could offer AP Pre-Calculus. Fayetteville High School chose not to offer it this year, but we will try to offer it next year. Just depends on how many people sign up. If only 10 people ask for the class, then it won't make. But if 60 people ask for the class, then there will be a couple sections of it. It, of course, would overlap some with this class, which is why you might be interested in some of it. You'll have to, do some of the same trig stuff, unit circles, SOHCAHTOA, all that kind of stuff. But for an AP level, they also have to do other things like conics and matrices, and of course the pace of the class will be much quicker because you have to go over a lot more content. But that is something else to think about. Of course, you need to pick out what best fits you and what best helps prepare you for whatever path you think that you're going to take. But if you have any kind of unusual choices, if you want to run that by me, that would be great. I can at least give you some insight on what the class would be like. So if there's something outside of those, again, you might just run it by me and at least see my opinion of that. So, is there any specific CAP questions you guys have, math related? I guess the biggest one that I would concern you about is, I know this is your 4th math credit for you guys, and you only have to have 4 math credits to graduate. So I know for some of you there's a temptation to not take a math your senior year if you're going to be a senior next year. And I don't have the data like ready to pull up or anything, but there is a lot of statistical data that shows if you take a year off of math and then you go to college and then you have to take a few more math classes to get your degree, that students generally are not nearly as successful doing that. So if you're thinking of not taking a math next year just because you have all your math credits, please reconsider and at least sign up for an easy math class so that you stay familiar with some of the stuff. But anything else you're welcome to ask me about anytime between now and CAP. So. All right, let me give everybody a few more minutes and then I'll go over 2 more examples, 3 and 4 with you. I do really want you guys to check your answers by graphing a couple, but I did upload on my website the solutions to all of them. So after you finish and you checked a couple by graphing, feel free to check the rest quickly by pulling the solutions up on my website. Make sure that you're got all of that sorted out. Okay, it looks like most of you guys are quite a bit further, but I'm going to go over 3 and 4. So if it seems like that would help, feel free to follow along with me here. Okay, so question 3. Again, I'm always plugging in direct substitution to start and hoping that that's enough to finish. But in this case, I get 0 on the top, 0 on the bottom, and 0 over 0. Indeterminate form could be anything. Just depends on how quickly each one is going to 0. So the only method you have to deal with indeterminate form right now, we're going to add multiple methods as we have more and more classes, but is factoring. So your numerator could factor out an x. Your denominator could factor out an x. Really, you probably want to factor completely. In fact, if you just factor it like this, cancel something out, you still get 0 over 0, which just means that you didn't go far enough. So this numerator not only had a GCF, it also was the difference of 2 squares. And so you had some x's that could cancel, and you had an x minus 3 that could cancel. So now that it has been completely simplified as much as possible, I do direct substitution for a second time, plug it into what's left over, and as long as I don't get 0 over 0 again, I can assume that that's my answer. So for question 3, answer should be 6. Anything specific about this one you'd like to ask? Okay, and then as much as I'm trying to verbalize it, question 4, I know what happens is you guys say, oh, okay, I've got to factor these, and you just start factoring right away. Don't do that. That's going to be a crutch to make today 10% easier, and then it's going to make it harder as classes go on, because as classes go on, the first step will still be direct substitution. Plug in 0. If you don't get 0 over 0, that is your answer. You are done. Don't try to make it more complicated than it needs to be. Always start with direct substitution and hope that that works. Okay, anything about 3 or 4? Okay, let me give you a few more minutes then, and then I know some people are getting close to being done with this, so I will give the directions on the Khan Academy in about 5 minutes. I know some of you are still finishing that up and still need to check your answers and stuff, but take a moment and find a stopping place for a second so I can show you the last part of today's assignment. And you'll either want your Chromebook or you can do this on your phone, either way. But in this unit, I like to assign a few different Khan Academy assignments. And the reason why I picked Khan Academy over just giving you a worksheet with a few questions is, of course, it's a little more varied in just that if you're doing well, you can knock it out in 4 questions and be done. And if you're struggling and you need more attempts and you need more practice, then you can redo it as many times as you need to get it to 100. So I believe you can either just log into your school account on khanacademy.com, or if you check your school email, I think it should have sent you a email yesterday when I assigned this one to you. So it is only 4 questions, which means that you can be done in 4 questions if you get it right. But this is over what we did last time, so I'm trying to force you to think about how to find a limit from a graph like we did last time. So you might want to take my recommendation to you on the class agenda. You can see I said spend like 3 minutes, 5 minutes reviewing number 65, because that's what type of questions it's going to be. Don't plug into that. No, there's people that walk over there. You can plug in somewhere else, behind you, back over there. Move your chair, move your desk or something, but don't block the path. So the questions are going to look like this, just like the stuff we did last time. Here's a graph. What do you think the limit would be as x approaches 3? Again, I can quickly reteach you if I need to, but I would prefer you to look at your notes first. The answer to this is not 4, but if you think the answer is 4, click check. It'll say not quite. Now, another nice thing about this Khan Academy here is you can click the Get Help, and it will walk you through your thought process, and you can see what you didn't consider or what you just didn't do correctly to come up with that answer. You can click Start Over, but I would like you to get 100 on this. You should be able to get 4 questions right in a row. So you can try it as many times as you want to, and again, honestly, they should be about 5 or 10 second questions, but since this is new to you and you might need to review it for a minute, that's why I don't mind if you retry it as much as possible. So if you have trouble finding that, students usually find that no problem, but I can help you if you don't see it. But your last 2 things to do today: finish up the back of this 67, check a couple by graphing, check the rest on my website, spend a couple minutes looking at what we did last time, how to find a limit from a graph. That's number 65 in your binder, and then do the Khan Academy. If you really know what you're doing, 4 questions and you're done. If you don't know what you're doing, you might have to restart a few times, but again, this is not something we're going to really spend a lot more class time on, so you need to be making sure you're up to speed here. And you got a ton of time to do that. You still have just a little bit over 40 minutes. So any of that I can help with, please let me know. But that should be it.